feel very safe and secure here on Earth. But that is only a psychological feeling. Actually, it is not so safe and not so secure as we normally think. The reason is that there is a celestial drama going on, and they are the ones who control our fate. So what is all this asteroid day about? I mean, that is about that our destiny is controlled by things in space. So that is what I am going to talk about it today. Today is the asteroid day, that is June 30th. And why it is asteroid day and why we are celebrating it is to be aware of the celestial drama going on in the sky. The point is that if we look at the sky, we see all the planets and all the stars and the sun and all that. And you get a wrong impression that the space is empty. That's why you are able to see them. But in fact, the space is very crowded. And this material in space, which we can't see with naked eye, but comes and gives their, message now and then. So what we have in space is right from the smallest dust particles, barely few microns, to fist-sized rocks, to asteroids, which are kilometer or hundreds of meter size, to comets, whose tail can be millions of kilometers. So there's a vast variety. They come in all size and shapes. It is like a zoo, actually. Smallest particles, where from they come, we don't know exactly, because it's a mixture of everything, from maybe planets and moon and maybe asteroids and cometary dust and meteors and everything mixed up. But about 40,000 tons of this dust falls on Earth every year. That's not a small amount. And we spend millions of rupees, billions and billions of dollars to go and collect these things from the space. But something which comes free on our doorstep, we don't really care about it. So way back in, I think, 50 or 60 years ago, we started this program of collecting this cosmic dust. Because where from it is coming is very important. We can't go everywhere and bring samples back as we do from the moon. They're far away. And some things probably come from outside the solar system. So in even distant future, we'll not be able to cross the boundaries of solar system. So it's a very precious material, and we must look at it to learn. Learn about our past, how our solar system formed, how life began. All these questions can be answered by these messengers. We can call them ambassadors from space, which come free of charge on our doorsteps. Now, what happens to this dust? It is, of course, 40,000 tons, let's say something like 10,000 trucks load of it, enormous amount, but it gets mixed up with dust from the earth. And it is like finding a needle in the haystack. We can never say this is extraterrestrial and this is terrestrial, because they are similar in many respects. But eventually all this dust goes and settles in the ocean with river water and rain and all that. So we go to the ocean sediments and we collect them. We go in the open ocean far away from the coast where the dust is less, and we can identify these particles. And many discoveries have been made based on the study of these particles of cosmic dust. In fact, I was myself amazed when we first saw that some of these particles come from a time before the solar system was formed. We call them pre-solar grains. Actually, these were identified in meteorites. So things formed in interstellar space, in clouds in the sky, far away, they somehow managed to come to us without any alteration, although they go through, billions of years of this chaotic environment and all that. But they are as serene and as pristine as we can believe. So that is one aspect. The other is these rocks which come and fall. And uh, there are thousands of them come every year, thousands and thousands. Of course, most of them fall in the ocean because ocean is a large surface area. And in places like Himalayas, which are not accessible, and deserts and, uh, forests and so on. But still a large amount falls on in our vicinity. So all we have to do is keep our eyes and ears open. And if you do that, we will be able to find some rocks. And it is really a fantastic feeling to have some cosmic body in your arm. I have this meteorite which I want to show you. I collected it way back in '76 in Dajala. You see, this is a small rock like this. We collected 500 pieces. And they are, of course, all in Geological Survey of India Museum in Calcutta, because that is where the government repository is. But I have this piece here for my work. I still study it. So this is very amazing. And, in the last 30 years or 35 years, we have been able to collect about 20 meteorites. Because fortunately for us, India is thickly populated, so nothing is missed, particularly in areas like Rajasthan, where everything is sandy, and in Gujarat and so on. We go there and, there are events. Even last week, somebody reported a fireball there. So purpose of my talk today is to bring awareness to young school children. So, because this is an ideal case of public participation in fantastic science. It is a science which cannot be done any other way except by these rocks. And you'll be amazed to learn that most of the knowledge we have about our planets, how moon is formed, how Mars is formed, planets are formed, what is there in comets, what is there in asteroids. All this has come by study of meteorites. So we know from this study that the universe was formed 13.8 billion years ago. The Earth was formed 4.5 billion years ago. The life on Earth appeared 3.8 billion years ago. And all the events, we have built a calendar of what has happened and how the moon was formed. Of course, we got the moon samples from Apollo and Russian USSR missions. So we know, and I want to tell you this story about 1969. That was a great year in planetary science. Many things happened that year. That is called a turning point in planetary science. First of all, a meteorite fell in a place called Alande. And that turned out to be the oldest rock we ever saw. They are 4.5 billion years old, but even a few million years older will have more information about the past. And in that, we discovered the very first condensates. When we say we, it means the meteorite people, the scientists who study meteorites very passionately. They take every rock and spend years studying it. They found rock grains, which were the first condensates, aluminum calcium silicates. They are the oldest things. And then later on, they also found things which I said pre-solar grains before even Earth was formed. They have come to us. The second discovery was the event was this Murchison meteorite which fell in Australia. That is a carbonaceous chondrite. Something similar we found here in Jaipur, near Jaipur, I think 2017. It is a carbonaceous chondrite. And what they discovered is amino acids, fatty acids, aromatic and aliphatic hydrocarbons. Oh my God, everything of which the life-forming compounds are made were discovered in that. So we have a hunch that maybe life on Earth came from outside, riding on these meteorites or riding on cosmic dust or these small dust particles. The third thing which happened, which was even more amazing, is that a Japanese group of explorers went to Antarctica. And there, you know, Antarctica is fully covered with ice and snow. And they found a bunch of stones there, and they were wondering how they came here. And they brought 9 stones back home and studied them and found that they are meteorites. Amazing. You know, here we have to struggle to find one meteorite, and there the meteorites get collected by natural processes, and they found a heap of it. And amazingly, about 25 or 30,000 meteorites have been discovered in Antarctica since then. Every year, people send expedition and bring these rocks. And we learned lots of things about them. Many of them, more than I think 2 dozen, have come from moon. Why go to the moon spending billions of rupees when nature brings them and puts them in Antarctica? So we have about 25, 30 stones from moon, similar number from Mars. We haven't got samples from Mars yet, but we have got meteorites. And of course, there are 40 odd places from where we have meteorites. So we can learn about these asteroids, planets, comets, and whatever by just studying them. So I want to tell you that what we have learned, the first thing we have learned is what is the universe made of? We call it cosmic composition. We know, of course, Earth is made of dust and soil, but the proportion of iron and magnesium and aluminum and silicon, all are different. But what is the composition of our original parent material out of which the Earth has been formed, or we are formed? So that is turning out to be very interesting. You know about Meghnad Saha, our great astrophysicist. Before Saha, it was generally believed, you know, if you look in the sky and you look at the various stars, they are different colored stars. You know, some will be blue, some will be white, some will be red, some will be pale yellow, and so on. People used to say that their composition is different. The elements they are made up of are different. That is why their color is different. But Meghnad Saha first found out that it is not the composition which is different. The composition is actually identical for all of them. It is the temperature which is different. So higher the temperature, bluish the color of the spectrum, you know. So he made a big discovery. And then Hans Suls and Harold Urey in USA, and I had a chance to work with them for many years. And they made a cosmic table. And that table was made using these meteorites. So what the original material out of which all the planets, the sun, and the ourselves are made of, that information has come from meteorites. I already talked about chronology. What is happening is coming from these meteorites, that information. What is the calendar of events? These meteorites spend millions and millions of years in space before they come and hit the Earth. because, you know, it is a three-dimensional space. Even if they come towards Earth to meet, it is a very rare chance. And we learn about cosmic rays from study of these meteorites. And that is the type of work I have been doing for last many decades. So it was amazing to learn that cosmic rays or the particles from the sun, we call solar particles, protons and all that, helium nuclei and heavy ones. They were there not only now when we can send satellites and study them, but they were there 4.5 billion years ago, roughly in the same intensity, same flux, same composition as it is now. It's amazing, you know, that things don't change much in the in space. So we learned the sun has been very active, and there are some indications that in the beginning, sun was more active than it is now for a very short period. So we call it early active sun. So we have a whole range of information. But the main point of my talk today is to tell you how our fate depends on these rocks. You see, Earth was very hot in the beginning. When 4.5 billion years ago, Earth was formed, it was melting hot. It took about 1 billion years for it to cool. And then all of a sudden, life appeared as an algae. Now, you need carbon. But when the Earth is hot, all the volatiles are lost through the atmosphere. So we were deficient in volatiles. So there is an influx of these volatile rich compounds from space, which gave rise to the life on Earth. So the creation of life itself owes to this dust. I talked about this 40,000 tons of dust. They bring the building blocks of life, the amino acids, the fatty acids, the compounds of methane, ethane, and all this. And many of them combine in the atmosphere of the Earth and or living bodies. That is one way. The other way is that life itself got formed in molecular clouds and comes hitchhiking on these rocks to the Earth. So creation of life itself has much to do with these meteorites. The point I want to make today, and this is amazing, that the nature uses the same mechanism of creating life as it uses to destroy life. Smaller ones bring all these elements we need for us to exist, survive, evolve. And sometimes they bring phosphorus and we have these moving animals. Sometimes they bring calcium and we have bones. Sometimes they bring other elements and we have evolution. The Darwinian evolution may be caused by influx of this variety of material from space. But when big bodies come, let us say hundreds of meters size, or a kilometer or 10 kilometers size, then they are very destructive. And you know about this big event happened 65 million years ago when dinosaurs, and not only dinosaurs, 70% of the life on Earth got destroyed. So the same mechanism, our creation of life on Earth and destruction of life on Earth, both are caused by these bodies which are brought to us in form of these small rocks, the fine dust, the big rocks. And you know, there is evidence, for example, 35 million years ago, that whole Earth was engulfed in a tail of a comet. You know, comet's tail is very big, millions of kilometers. And if it comes and the Earth can be engulfed, the whole Earth can be immersed in that tail. And comets, you know, are made up of many organic compounds. They are found out by spectral studies and so on. So they bring all this material required for our survival, our evolution, our progress. And this is why I think that life from simple algae or amoeba-like single cell material has evolved to uh, highly, accomplished complex brain and all this. Human beings over 3.5 billion years, because input from space. The material we need is brought in form of this dust from time to time and small rocks. And there are evidences that when a 10-kilometer sized body came and hit the earth 65 million years ago, then it destroyed 70% of a species on the earth. Dinosaur is only one of them. But you see, this big event triggers a chain of processes in the atmosphere. And I just want to describe you briefly what happens where a big body comes in through the atmosphere and hits the earth. First of all, they come with such a tremendous velocity. Their velocity can be, tens of kilometers per second. We are familiar with car velocity. This is tens of kilometers per hour. And this is 3,600 times more than that. So it comes with tremendous velocity. And we have all learned that energy is proportional to half mv square. That is square of velocity. Tremendous energy is deposited in the atmosphere. So there is a heat wave first. Then when it hits the earth, a lot of dust is thrown out. Imagine a 10-kilometer body coming and hitting. It will produce probably 200-300 kilometer size crater. And so much dust will be thrown in the atmosphere. So much so that the sunlight will be stopped. We will be shielded from sunlight for hundreds of years. So if sunlight doesn't come, there's no photosynthesis, no vegetation, no plants, there's nothing to eat. People will die of hunger. And not only that, when it hits the earth, then there'll be forest fires. All the forests will burn. Some people claim that even our volcanic episode of Deccan, Deccan volcanism spreads from, let's say, from Kutch in the west to Nagpur in the east to Hyderabad in the south, a very big area. All this was triggered by that 65 million year old impact of a 10-kilometer body. And we found in our study 2 sites in India, one in Kutch in Anjar and one in Meghalaya in the eastern end, where this dust of this meteorite is deposited, which came and hit the earth. So you see that life can be destroyed not only because of direct impact, not because of direct impact, but because of the processes which take place in the atmosphere. So accompanying this forest fire and volcanism, by chance, if it hits ocean, for example, as this 65 million year event hit, it hit actually Gulf of Mexico in USA. A tsunami will be produced. Supposing such a body comes and hits Arabian Sea here, we expect about 300-meter high tsunami. It will come and pass through the whole country, go to Bay of Bengal, sweeping all the buildings, everything, humans, animals, trees, plants, and everything, taking them together. So it can be very catastrophic. So probability, of course, we don't have to be scared. I mean, it can happen today or tomorrow. We don't know, because it is all stochastic. It is not predictable. But usually such events happen once in 100 million years. And amazingly, they found that event in which dinosaurs were killed occurred in June. I was myself amazed how to say 65 million years ago, the meteorite came and hit in the month of June. Let me tell you how they discovered it. The dust which was back deposited in a few uh, 1 or 2 days, all the and then when they dug the earth, the soil, they found lilies, flowers in full bloom. And flowers, those flowers, it is known, bloom only in the month of June. So that is how they came to the conclusion that that big body which destroyed life on earth must have hit the earth in the month of June. So June is a very fantastic month because another event, this is a very big body. As I said, once in 100 million years, it will come and fall. But every century also, smaller bodies will come and fall. The smaller the bodies, more frequent is the fall. The fist-sized body like this falls maybe day. The 100-meter body comes and hits every century. And one such body came and hit Tunguska in Siberia. But that was a very amazing event, very memorable event, in which nothing was found on ground, no rock was found, but all the trees in Siberia, in this Tunguska area, there are a lot of trees, they all fell by pressure waves. So scientists concluded that maybe it exploded in the atmosphere itself. And because of the pressure, the high pressure of the air, due to this fast coming body, all the trees fell. And that happened on 30th June. That is why we celebrate Asteroid Day on 30th of June, because Tunguska event occurred on 30th June 1908. And this is about time, because this happens once in a century. A century has just gone by, actually another 13, 14 years more. So this event is bound to occur. Of course, it is statistical. It can happen now, or it may not happen now. It may happen after 10 years or another 20 years. We don't know. But the reason why Asteroid Day is celebrated on 30th June is because Tunguska event happened on June 30th. So two events I talked about. The big event which killed dinosaurs occurred in June. The big event with the trees of Siberia fell down flat on the ground occurred in June. So June is a very tricky month we have to be aware of. Only, of course, we have only two events. But normally they fall equally in all the months, these stones. And as I said, we have learned composition of our planetary system, composition of the sun, composition of the galaxy, when was it formed, and all this. This information has come from study of meteorites. So purpose of my talk today is to make you interested in meteorites. And if you keep your eyes and ears open, very likely in one's lifetime, you will find one meteorite. And the data are such that even if you say that 1,000 or 2,000 meteorites fall on the earth every year, then in 100-meter square area, in 100 years, one meteorite is bound to fall. So in your immediate neighborhood of 10 kilometers, in your lifetime, you will surely discover one meteorite. And I would like to urge that you please become a meteorite hunter, because so much precious information is there. And thanks to our Apollo mission, we have developed techniques in the laboratory in PRL where I used to work. We can take one small grain of few microns and study all isotopic composition, chemical composition, mineral composition. We can date it, find out when it was formed, and many things. We studied this Mukundpura meteorite, which fell in near Jaipur, and we found 40 organic compounds in that. It is like coal, charcoal, dark, black, and it was about few kilogram, 3 or 4 kilogram size body, which came and hit, the ground, a farm of sand. And even sand is very soft, but it broke into hundreds of pieces. And we got, I think, 2 grams out of it. I don't have much time to describe all this thing. But in the 2 gram, the amount of work one can do today with these techniques available in the laboratory are enormous. And we were really happy when we found isotopic composition of nitrogen and these amino acids, 18 of them amino acids, which form all our living bodies in that. So my point is that there's a wealth of information. Whatever we have learned about our solar system, we have learned from meteorites, and we must not ignore it. We must collect it and study in the laboratory, because a stone is a stone unless it is identified, its chemistry, mineralogy, chronology, and all that, then it becomes really a precious stone. And more amazing than all this, what I have said is, in last 20 years, we have found that 2 bodies from outside the solar system, large bodies, not small ones, we can see them with telescope. They came from outside the solar system, from the galaxy, came very close. Of course, we couldn't catch them. They didn't fall on the Earth, fortunately for us. Otherwise, it would have been catastrophic. But things from outside also come. And maybe they come from other planets. There is an asteroidal belt very close to, between the orbit of Mars and Jupiter. There's a Kuiper's belt beyond the orbit of Neptune. Stones from there come naturally by gravitational perturbation and fall on the Earth. And we can identify and we can learn about them. And as I said, there is evidence that at least once or even more times, a comet has really covered the whole Earth. So what is comet made of? We don't know, because it is 100,000 astronomical units away. 1 astronomical unit means distance from sun to Earth. And it is 100,000 astronomical units away. We cannot go there. So they are coming to us in a natural way. And it is really very thrilling to take a grain and learn so many things in our laboratory. So if you happen to go to Calcutta, please visit the museum there of Geological Survey of India. And the last point I want to talk to you about is about the craters. When meteorites fall, as they do on the moon, maybe 10 times more fall on the Earth. But moon is a highly pitted surface. There are craters and craters and craters. But fortunately for us, the nature has given us an umbrella of atmosphere. So when these bodies come through, they slow down because they first meet the atmosphere, a thick atmosphere. They slow down, and our Earth is not so highly cratered. Otherwise, we won't be able to survive here. Because of the atmosphere, we are able to survive. But when they fall, they create craters. And, there is the famous crater, Dr. Bharat Adur mentioned about it in Lonar. When you go next time to Ajanta, please visit this Lonar crater. There's another crater we have found in Ramgarh in near Kota in Rajasthan. There is yet another crater, very big one, which Jagdish Pati has found in Vindhyans. It is called Dhala crater. It's a very big one. And there is a talk about a crater in Kaveri Basin. And there is a gentleman called Mahesh Patil, who thinks in Himalayas he has identified many craters. So how to identify it? This is the last topic before I close. How to identify a meteorite? So one is you will see a fireball. Fireball means a streak of light, very bright light, football-sized light, ball, maybe red or green or yellow, or if it is very bright, it can be blue or white. It is so bright that it is like full moon. It will pass through the sky, and because the material will burn, 90%, 80%, sometimes 95% material burns in the atmosphere. Only a very little one reaches the ground. So you see a fireball, that is first indication. You track it down, you put a camera on your car or your house, it will tell you in which direction the fireball went. Go there. I myself found about 20 meteorites. So it is not so difficult as we think. You can go to the spot, ask people. And when you find something which is black from outside, because it is burned, it is heated to a few thousand degrees on the surface. Inside is not so dark. And then it is magnetic. So that is another way of identifying a meteorite. And then most of them smell of sulfur because they contain sulfur. You know, sulfur cannot exist on Earth because it will be oxidized in our oxidizing atmosphere. So if you smell it, it will smell of sulfur. It will be magnetic. Its density will be very high. It can be more than 3. It can be up to 7 if it is iron meteorite. You know, they come in many varieties, these stones, but 3 main varieties are there. Stones where density is 3 to 4. Irons where density is 7, about 7, because it is mostly made of iron and nickel. And the mixture of the two, stony irons we call them, with density between 3 and 7. Whereas, you know, earth rocks have density below 3 generally. So if you just hold it in hand, you will know if it is a heavy, then it is a meteorite. So I have told you that there are many ways of finding a meteorite, identifying it from or distinguish it from ordinary stones lying outside. And this is a smell of sulfur, magnetism, density, color, a dark crust on the surface. Even shape is changed because it has got burned or ablated, as we call it. So there are many ways, and of course it will be in a crater because it is coming with cosmic velocity, and of course accompanied by light and sound. It creates 2 types of sounds. If it breaks, it creates just like a bomb, you know, explosion of a bomb. So as the meteor, as the stone comes through the sky, and if it breaks, it will produce a sound like a bomb. But if you are directly underneath, you will hear a hissing sound like that of a cobra, because so much pressure change is taking place in the atmosphere as it travels through. And if you are nearby, you will hear a hissing sound. So all these are symptoms. And you know, if you don't study a meteorite, it will only remain a stone of no value. As a, you know, something fell during the period when Jahangir was the emperor, and somebody, it fell in Banaras actually. Somebody went and presented this to Jahangir. It was iron meteorite. And that he was, of course, not having a scientific bent of mind. So he said, make a khanjar for me as a memento. And he made a dagger, and he was always keeping with him. So, but we are, of course, better educated, and we know the scientific worth of these stones. We can learn a lot about our solar system. So with this brief introduction, I'm sorry I could not show you any slides, but maybe some other time. But I tried to tell you in a nutshell that it can be very exciting to look for a meteorite, and even more exciting to find one and even more exciting if you learn something new from these stones. So with these little stories, I just want to close here with the message that creation of life on earth is due to these rocks in the sky. They determine our birth, the formation of life, and the destruction also is due to the large meteorites. So nature uses the same mechanism to create life and destroy life whenever it wants. And these things are unpredictable. Anything can happen anytime. A big body can come and hit. So to bring this awareness, many space agencies have put telescope who look for these bodies in space, and they can warn you in time, I guess. So you can go to some safe place, high place like Himalayas, and save yourself from tsunamis or something, which might destroy forest fires and all that I talked about. So it is very amazing to learn how nature works, and it is equally amazing to learn what these little rocks tell us about the universe. Thank you very much.
Can we have small questions? Because the next speaker would like to. So if there are any small questions for Professor Bhandari,
Yeah, if there are questions, I'll be happy to answer them. Yes.
Yeah. Are there any questions? As I see, there are Anand.
Sir Bhandari, I have a simple question. You said some many organic molecules, something was also found. How
Yes.
did those organic things survive this burning through the atmosphere?
No, yeah, that is the point. You know, the nature has a way. The burning is only on the surface. And meteorites are very poor conductors, except for the iron ones. The heat does not conduct inside because it takes only 1 or 2 seconds for the meteorite to cross the atmosphere. Let us say it comes at 20 kilometer, 30 kilometer per second. So to cross the atmosphere, it will take only a couple of seconds. During that period, the heat does not penetrate. So inside is all preserved. It is the outside which burns. And that also is a very fantastic mechanism. It doesn't get heated. It gets volatilized immediately. So if you slowly heat like on a stove, the heat will conduct through and heat the whole body. But it is instantaneous transit at very high temperature. So surface burns, but inside remains cool. So that is an amazing mechanism how these things survive. I hope I have made it clear.
But I think then it's kind of a composite thing then, right? So the nickel core or some metallic core and the organic volatile thing, that ice-like thing precipitates surrounding it. And many of them became together and they have the organic thing deep inside.
Yes, that is true. There are groups of meteorites. You know, rocks are formed 2 ways. One is by melting, like volcanic rocks you have. You melt the whole thing, it crystallizes and forms rocks. But in space, the dust can get together and like you make laddu by little grains coming together. Because of compaction and collision and all this, they become very compact bodies. And inside, everything survives in a pristine way. So most of the meteorites, particularly these carbonaceous chondrites, these other chondrites, the ALH and other groups chondrites, they are like laddus. Get compacted and then they can survive because nothing much happens. Of course, they break also if something comes and hits them. meteorites like these eucrites, non-chondritic meteorites, iron meteorites, they are formed by melting. And from there, we have learned that very early in the history of the solar system, asteroids melted. And what was the source of heat? That is very important. It is a question which was debated for a long time. And in one of the meteorites, Pipalia Kalan, which is a eucrite we found in Rajasthan, Srinivasan is there also. We proved that it is because of radioactivity content in the early rocks that heat is produced. This is a proposal which was given by Harold Urey, because source mechanism was collision, that is not enough energy. But radioactive heating due to an isotope called aluminum-26 is enough to very quick. The other rocks is, and then finally they are brought to us on Earth later on. Is there now any other question?
Hello, good morning, sir.
Good morning.
I'm CS Pullivar, Education Officer from Nehru Science Center. And I have one question, sir.
Yes, please.
Long back, we have visited this lunar crater. And there are lots of small white crystals around. So
Yes.
how these crystals form there? And what is the composition of these crystals? Can you throw light on this, sir?
No, you see, there are lots of things there on lunar. First of all, let me tell you two things which are definitely due to impact which we found. One is the tektite-like bodies. They are found near the northern rim, outside the northern rim, about maybe 100 meters away. First discovered by Dr. Nayak, and later on we found them also. And these are the tektite-like things like droplets or two drops joined together, or roundish things, spherule-like things. They are formed because of the impact and then thrown out. The other thing we found is glass. And we dated this glass. There is a glass rock with a glassy surface. So, you know, lunar is formed of, made of basalt, and the glass is formed. So we found lots of rocks with a glassy surface, and we dated that glass, and that comes out to be about 40 or 50,000 years. So Dr. Sen Gupta had done lunar formed also, we know roughly. But these, they are, I don't think they are due to impact. They are due to evaporation of water. Fortunately, I should say unfortunately, a dam nearby and a lot of water comes, and you know, lunar is in a plateau which is very hot in summer. So most of the water evaporates. So these, I can imagine only, I have not seen these white crystals. If you send them to me, we'll examine them. But white means they are mostly calcium salts, and they must be the evaporite products due to the evaporation of water of the salt which is dissolved in the lake. So I don't think they are extraterrestrial.
Good morning, sir.
Good morning.
So my name is Dr. Salil Dhamankar. So please, forgive my silly question, but because I know more of the inner space than outer, because I'm a medical doctor, so I don't have really any, much knowledge of this subject. But I heard you mention that these rocks from space come from inside the solar system, do they also come from outside the solar system, like through the interstellar space? And if they do, how do you differentiate between them? And the
Yes,
second,
you are right. Let me answer this one question. Most of them come on Earth from asteroids, from Moon, from Mars and nearby planets. But in the last 20 or 30 years, two bodies, rather large bodies, which have come from outside the solar system, from the interstellar space. And we can only tell why they are from outside the solar system is because of their orbital characteristics. If something comes from within the solar system, it will have a elliptical orbit, as you know, Keplerian orbit going around the sun, then comes once in a while near the Earth and get captured by Earth's gravity. But when it comes from outside the solar system, it will have a hyperbolic orbit. So it will come. So we traced the orbit of this body because this was this is a cigar-shaped body, one of them. If I had slides, I would have shown. But anyway, it came and we traced its. We determined its semi-major axis, but it is very big. So it is a hyperbolic orbit. It came at it and it went back in space. Now, unfortunately, we don't have a mechanism to go and land there or capture it or do experiment with it. Only thing we could do is with a telescope determine its orbit, because it takes quite some time as it passes through the, goes around the sun and goes back into space. So 2 or 3 bodies have been identified, which are coming from galactic space. Yes, you have another question, I believe.
the second part is, in the event that I found meteorite, okay, whom do I report to? What do I do with it?
Yeah, you see, if you find a meteorite, I told you about half a dozen things you can do yourself, like you can measure density, magnetism, you can check whether it is magnetic, look at the shape and all that. And once you are reasonably sure that it is a meteorite, you can, of course, send it to me. In the PRL, Physical Research Laboratory, we have built techniques where almost anything about meteorites can be done. So number of things we do, for example, we make a section and look at under microscope, what are the minerals it is made up of. We look for these round balls called chondrules, which are only found in meteorites, not on Earth. We can look for these, what you call highly high temperature minerals. We can look for, we can do the chemistry, not anybody can do the chemistry because it's very tricky, because there is a contamination from earth dust and all that. And we can classify it. That is called classification. If you know chemistry, petrology, and little features about shock and all that under microscope, you can classify it. But then comes the real work, where you have to do isotopic composition, and Dr. Srinivasan is here, and PRL, we have Dr. Kuljit and many other people. They can measure isotopic composition of, let us say, oxygen isotope. The oxygen isotope in Earth and meteorites is different. And that is like your DNA. It can tell you where from it is coming. Mars has different oxygen isotope, Moon has different, and other planets have different, and so on. Then we can do nitrogen isotopes. And all this can tell you where from it is coming. And then we do rare gases. So rare gases tell you how long it has been in space. So it turns out that stone meteorites have something like 100,000 years to something like 20, 30, 50 million years they spend in space before they come and hit the Earth, asteroid or other planet. They take hundreds of million years in space. So all these studies can be done. And then finally, it turns out that every meteorite is unique and has some new information to tell us. And of course, I talked about organic compounds and a variety of things, whether they are left-handed or right-handed, whether they are chemically made or made by life. And sometimes, people doubt whether there are some remnant of some bacteria there, some gases there. They study methane and things like this. So there are a lot of things which can be done. There's a whole series of sequential analysis which we can do, and I'm involved with many of them. So of course, one thing I forgot to tell, most important is radioactivity can be measured, and radioactivity distinguishes a meteorite from Earth rocks, because some radioactivity cannot be produced on Earth. Now, that is a sure sign that it is coming from space. And then we can do some other studies like particle tracks and all that. So about 20 studies can be made on a rock, and all of them can be made in PRL, which the laboratory was developed over the last 50 years with all these facilities, and can all be done with a few milligrams or maybe at most a gram of rock. So without wasting this precious sample, a lot of work can be done. So if you are interested, you please get in touch with me. I'll tell you how to proceed when you find a meteorite. And I'm sure everyone here will find a meteorite, because I went to this Dajala school to search for these meteorite rocks, and 200 students searched about 18 kilometers of distance, walked barefoot on that, found 200 pieces. Everybody got one piece of his own. And 75 kilograms, 500 pieces in all we collected. So it can be very rewarding to look for meteorites.
Thank you so much.